As part of our ongoing series on Maine's changing climate, our team of meteorologists have been tackling what experts say are some of the biggest myths about global warming.
Tonight, Keith Carson takes on the one that many climate deniers believe is still true despite evidence.
We're down now to the #1 climate change myth. The climate has always been changing. What I hear over and over again is, how do we know it's us? How do we know it's not just a natural cycle? I get it. After all, at one point, Manhattan was under a mile of ice. Climate change has happened before. But scientists have been sure since the 1960s this change in the climate is being caused by humans. So how do we know? Let's start with the most obvious driver for a warming Earth, the sun. There are a few reasons we know the sun is not responsible for a recent warming. First, the measure of incoming sun energy to the Earth, solar irradiance, has remained flat or actually decreased as our temperatures have rapidly increased. This is especially evident since the 1970s. Another reason we know the sun is not responsible for our current warming, the air high up in the atmosphere, known as the stratosphere, has been cooling since the late 1970s. That stratospheric cooling has been taking place while the troposphere, where we live, has been warming rapidly. Think about it. If it was the sun, how could the layer closer to the sun cool while the layer beneath it warmed rapidly? The answer is, it's not possible. That's how we've eliminated not only the sun, but any external influences in space. Now, carbon dioxide is a greenhouse gas. We've known that since the 1850s. And since the 1850s, we've known that greenhouse gases trap warmth in the lower part of the atmosphere. This has generally had a net positive effect for life on Earth as it keeps it inhabitable. But too much of a good thing can have negative impacts. Using ice cores, which contain trapped air bubbles from hundreds of thousands of years ago, scientists have recreated the history of carbon dioxide in our atmosphere, and the graph is striking. So while there have certainly been natural variations in carbon dioxide in the past, nothing approaches the scale and speed of our recent run-up to over 400 parts per million. Still not convinced humans are responsible for the recent surge in carbon dioxide? What if I told you we caught fossil fuels red-handed with a fingerprint? There are 3 naturally occurring carbon isotopes on Earth, C12, C13, and C14, the last of which decays radioactively to nitrogen with a half-life of about 6,000 years. Why does this matter? Well, because of that half-life, carbon that is pulled out of fossil fuels that have been in the ground for a long time prior to burning demonstrate the C14 isotope is almost entirely gone. In addition, plants hold a lower percentage of C13 compared to the overall atmosphere. So, by measuring the percentage of C13 and 14 isotopes in the atmosphere's carbon dioxide over time and seeing them plummet, scientists can easily conclude that not only is CO2 increasing, but that CO2 is definitely coming from the burning of fossil fuels. This phenomenon even has a name, the Seuss effect. Now, CO2 is a greenhouse gas. Greenhouse gases warm our atmosphere, and fossil fuels have added CO2 to the atmosphere at an unprecedented rate. It's pretty much a 1 + 1 = 2 equation. And last but not least, the speed of warming. Although the climate has changed in the past, it has never warmed or cooled at this speed. Now you might say, how do we know what the temperature was so long ago? Scientists use a complex process of temperature proxies, such as something we see here a lot in Maine, snow. There are measurable chemical differences in snow formed at different temperatures. Therefore, ice cores can be used to provide a record of temperature going back around 250,000 years. In addition, yearly banding is found in fossilized corals and lake sediment. Each band has a chemistry that reflects specific temperature ranges. Tree rings are also used as they get wider or thinner based on the temperature. So scientists can say with a relatively high degree of confidence, the Earth has never warmed this quickly before.